Welcome, everyone, to Dev Network's Developer Week webinar series. I'm Patrick Gallagher, and I'd like to welcome all of you to this week's featured webinar presented by Splunk, a sponsor of Dev Network events and webinars. Splunk is the world's first data-to-everything platform that empowers IT, DevOps, and security teams to transform their organizations with data from any source on any timescale. So, before we get started with speaker introductions, I have a few housekeeping items. First, I'd like to remind our attendees that live chat and Q&A is available during this session, and you can raise your hand in the chat or ask questions in Q&A in the Q&A section of the webinar viewer. So you're looking at the webinar viewer. On the right-hand side, there are tabs. There's one for chat and there's one for Q&A. So you might want to click on Q&A or the chat, and you can put in your questions. And we will also be doing some polls throughout the webinar. Questions will be answered at the end of the session, at the end of the webinar. And finally, this webinar will be recorded and made available within 24 to 48 hours for additional viewing. That invitation will be emailed to you. You'll be able to check out the webinar after watching it, or you can forward on to your coworkers so they can check it out as well. So, on to the introductions. Joining us today is Splunk's Senior Technical Evangelist, Dave McAllister. Providing technical evangelism for Splunk, Dave works with DevOps, developers, and architects to realize the advantages of modern microservice architectures and orchestration in distributed systems, especially for today's fast-moving cycles. So, without further ado, please welcome Dave McAllister. Dave?
Thanks, Patrick. Thanks for that great introduction, and hello to all of y'all out there as well. One of the things that y'all have heard the bank has 1 million points of data, so let me share 3 of them of mine real quick with you. First, I'm owned by 3 cats. I'm used to being ignored, but hopefully you'll be able to pay attention to what I'm talking about during this talk. Second, I spent 10 years as a soccer ref, which means I'm used to people disagreeing with me. In fact, I pretty much can guarantee that anytime I was on the field, that exactly half of the people I was working with would disagree with me on every single call. And third, I'm married, so I'm used to and have proof that I can't read minds. Please use the chats. Please feel free to ask questions at any point in time, and we'll get the answers to you one way or another. So, today we're going to talk about RED, which is a monitoring pattern that's heavily used inside of microservices. But to do that, we need to talk a little bit about what monitoring is and what observability is. And if we think long enough and go far enough back here, monitoring actually kind of started with the concept of asking the standard questions. Are the lights on the server blinking? So the server is actually up and running something. Is it plugged in? And then we evolved to the Network Operations Center, the NOC environments, that we started keeping track of everything that was going on with screens wrapping around walls and people staring at screens, either in a light room or in a darkened room. But nonetheless, that's what monitoring used to be. And that was because we really were monitoring at a very, very discrete level that was a large box model for here. But we've now moved into a new world. We've now moved into microservices. We've now moved into cloud architectures. And with that, we came into this concept of observability. And observability is the quality of how we find out what the system is doing inside of the system. And in terms of the true definition, defining the exposure of state variables to allow inference of the internal behavior of a operating system for that. But the problem is that with the more access to data, the more information that came into this, we actually started getting more noise involved. And so people started believing that observability was a signal to noise problem. And while that's definitely the case, there is more information coming into this. It's not a signal to noise problem, it's a signal not noise problem. Generally speaking, you're going to approach the massive amount of data that you have coming in here by aggregating it, analyzing it, and displaying it in ways that make sense to your environment. With microservices, we can have hundreds, possibly even thousands of different instances running at any point in time. Operational data comes in. It's not really filtered as much as it's aggregated inside of here, and then it's saved and displayed in ways that make sense for us to approach for that. It's also not one-dimensional. Generally speaking, it consists of logs, monitoring events, tracing, and anything else that makes sense. In fact, I have a customer who literally feeds their Twitter feeds into a sentiment analyzer and then uses that as one of their observability aspects, because their customers always tell them something seems to be going wrong long before the system actually sees something going wrong here. It has to include the concepts of metrics and time. Metrics simply because they are the fastest way that we can get responses to set alerts and so forth. And time, because things happen in order here. And it's got to cross all these things. And bottom line, once you're in the space, anything that slows you down is a bad thing. So you want to actually make sure that you're living as close to a real-time clock as possible. We think of these pillars of observability, and they're actually data classes, if you will: metrics, traces, and logs. And each of these pieces gives us additional sets of information. Metrics: do I have a problem? Traces: where is the problem? And logs: what's causing the problem? But when we look at monitoring, we're really looking at more the metrics capability here. We're looking at what the data is attempting to tell us is going on inside of this overall environment. So, metrics, traces, logs, wow. Well, everything is an event. And this is really important to understand. When something happens, no matter what it happens, it's actually an event. And events can be aggregated to be larger events. They can be event streams. They can be a lot of things. But events only exist if they are recorded and measured here. And with these things, metrics are incredibly compact, easy to compress. They're efficient. They may not be sufficient to solve your problems or understand the operations of your application space, particularly on failure cases. Logs are full fidelity. They are we used to call this that logs are the source of truth, because everything comes from there. Traces are cool, but they do require work to be able to establish inside of here. But because metrics are compact, efficient, and really come in a streaming model here, they are very useful in looking at microservices environments in particular. So just to finish up, because I spent a lot of time talking about this observability thing here, the duality of observability is something called controllability. Telemetry is our inputs. That's how we get these metrics coming into here. And we need to make sure that we're not just limiting our exposure, our monitoring practices to just being able to visualize. We need to be able to do analysis work, and we need to be able to respond to it. And so the duality of observability, being controllability, also applies into any monitoring practice that you look at. You need to be able to close the loop, whether it's a human closed loop, an alert goes out, or an automated closed loop and a runbook gets executed for you directly. Those are really important. So with that, we start looking at what's happened. And it started with a little bit of this back in the blinking lights era. And it was always fascinating if you go back in the history of large scale computers, how much time was spent on figuring out how to place the blinking lights so that you could see what was going on. There's I think an SGI computer, the Onyx, for instance, that the blinking lights actually were showing you the amount of instructions going into a CPU. And so there were 8 of those signals, and they would blink at the rate that the instructions, the pipeline was being fed into the CPUs. Fascinating to watch, totally useless for figuring out what was going on, except whether the computer was doing work or not for this. But in mainframes, we had this tightly coupled model. The applications were pretty much application to machine. And so we could go look at the blinking lights and see the machine was working. As the cloud started evolving, And we started moving into a model where we had third-party services providing data. And we started moving into containers, into Docker, into orchestration. We started changing the nature of how our applications were built. Two things occurred inside of here. One, communication pathways became really important for this. And two, we actually didn't own or even know where something was looking. We couldn't go look at the lights anymore. And finally, when we get to what's called cloud native, everything is loosely coupled. Every microservices is doing something. We started bringing serverless functionality into this, and we started having both public and private clouds that appeared inside of that environment. And so those things all started adding up together to make our lives a lot more complex. Monitoring had to adapt to do that. And with that, we needed to make sure at the same point in time, we could understand what changed, what the impact of the change was, how things were built inside of here, and at the same point in time, have the ability to respond to changes in our business environments at blinding rates. And so microservices really were that. Microservices are collections of services that do a service and do it extremely well. Microservices are independent so that they can be deployed independently inside of here. And something to keep in mind is that a microservice is not as small as possible, but as small as necessary. Do the service that it needs to provide completely and not have dependencies that grow outside of that. So microservices are a design pattern, and they can be written anywhere you want to. They can do a black box model, it's simply there. But along with that came into this new thing, starting with sort of the agile environments here, now into the DevOps world. You built it, you run it, became part of this. We no longer were pushing things across the wall. And so what happened was monitoring also had to cross the boundaries between the traditional IT ops space as well as the now dev space, or what we call the DevOps practice or DevOps philosophy space. So the architecture that you look at is literally everywhere for this. And this is a fairly standard example. This is an Amazon screen purchasing something inside of here. What you're looking at from a user viewpoint looks like it's basically one thing. But behind that are a number of services that are driving across there. In this case, I've got your account information, I have your shopping cart, I have the pictures and images, I have the product set, I have its availability set, I have its rating set, all of these things across here. And so honestly, even though it's not, I haven't circled all of the ones or squared all of the ones, I guess, for this, the product that you're looking at, this front page is made up of somewhere between 17 to 21 first level microservices. And behind every one of those services is somewhere between another 3 to 7 microservices that are being touched just to provide each of those little blocks of information. So all of a sudden you can start adding up and see that you're going to be running roughly 50 microservices to display this single page for that. Multiply that 50 services times whatever number of compute instances we need to match the workload on an Amazon Prime Day. And all of a sudden you can start seeing that the volume needs to be handled. And there is a massive volume that scales up and down in response to user request and user requirements. And so those things start all becoming pretty interesting. And traditional monitoring didn't get you there. So not only are we dealing with the stuff we wrote, we also have third-party data that comes into here. Again, for instance, in the same product set, I'm pulling images. Images are coming probably from a third-party feed of some sort. I have a database probably inside of here. The database for product data is probably not something I wrote myself inside of that. The inventory feed, maybe I wrote part of it, maybe I didn't. I set price. All these pieces become the interesting pieces. And each of these pieces could be written by a completely different team, dispersed across the entire world. You simply don't know, but you need to be able to communicate well between those things here. So with that, let's kick off the first poll. So just to talk a little bit while y'all are answering the poll information here, one of the things we know is that you probably are monitoring your applications somehow today. But it's always interesting for me to see how people are doing this, or even, if you will, whether you're doing this or not. So we'd really like to get your inputs on what's going on in your actual current environment. Okay. So let's, if we can go ahead and close that poll out, I'm going to step to the next slide. So monitoring itself, when we get into this, has some basic questions. And it's kind of unique and interesting to understand what's going on here. And they really started in the case of saying do you think there's a problem? If you are, are you sure that the system has actually ever performed the way you thought it should here? What's the environment underneath the system? And so it's not purely an application question. It's actually how all these pieces work together here. Can you say things are running well enough? And if so, did something change that you should know about? Again, in a microservices environment, for instance, services get changed. It is not unusual to see between 10 to 20 independent services being pushed in a scaled environment on a daily basis. So you could have 20 updates inside of that on a single day basis here. What changed? Because your errors may not show up where the actual change occurred. But in a microservices environment, we have that question again. We have to understand that we can have thousands of independent services running here. How do you know if your individual service is healthy? Keep in mind that the individual service, it may sound singular, but it actually may be broken into multiple underlying hardware scenarios. So in a Kubernetes environment, for instance, you may have a single service payment that shows up, but your payment service may be running on multiple containers in multiple pods across multiple worker nodes. How do you know what an individual service is doing versus the application service in here? So what's the performance of the service instead of here? And then finally, how do you actually troubleshoot and debug an individual service? And so this changes the nature of the game again. We're not looking at, here's the application. We're not looking at, here's the infrastructure. We're looking at how these cross the boundaries for that. And that leads us to the modern class of monitoring patterns here. And these started really evolving with what's called Google Golden Signals, or latency, saturation, errors, and traffic. I tend to use this order a little differently. I usually do it as latency, errors, remember LSAT as well for this. But while LEST was really useful for the Google model, what we quickly determined was that there are specific use cases even inside of that we needed to be able to drive across. And from that, we ended up with utilization, saturation and errors, and rate, error, and durations. If you notice, there was a common element across all of these errors. Errors are always important, no matter what. Yeah, I did notice on the chat that my audio may be breaking up. I am suffering massive bandwidth problems, so hopefully it will come back in for this. But nonetheless, we have these three categories. I'm going to spend time talking about red monitoring. This does not mean ignore use. This means that red is really targeted towards this microservices model. So why red? Well, first of all, complexity matters. As we've seen by looking at this, red will tell me a tremendous amount of information about what the moving parts are, what the interrelations are, while also giving me the ability to understand what not is no longer there. We live in an ephemeral world here. We've got lots of data coming in here, so we need to be able to simplify it. We need to be able to abstract and aggregate it to get rid of some of the clutter. But we also need to be able to drill into that massive data lake so that we can figure out what went wrong and understand what's happening. And with the networking bandwidth concerns going on here, red may not help the networking bandwidth concerns as much as I'd love for it to do, because otherwise I would be sending this off to my internet provider and basically telling them that they needed to fix their problem. By the way, use would help a lot here for that. We're looking more at an infrastructure issue. So red is a subset of Google's golden signals. So it's related to the site reliability engineering, SRE related here. And it was originally mentioned by a company called Weaveworks, and my call out is to Tom Wilkie, who came up with this concept. It was designed for request-driven systems. And in particular, it was designed for the microservices-oriented functionality. Red is not limited to microservices, but it does need a request-driven model. You need to be able to track a specific request that's going on. It's also most useful where you can actually isolate the services aspects. The value to that is that inside of your application, even if it's not written in microservices, you probably already do have some capability of understanding when you have completed a functionality piece inside of here. And red will help you understand and drill into that. And in fact, even in the simple example that you're looking at here, where the API looking at catalog, checkout, and so forth, checkout as an independent microservice has multiple functionalities that I can also start drilling into. So red is really focused on the microservices types environment for this, but it's not limited to that. It doesn't really help you that much if you're doing batch processing. So keep that in mind here. And if you're doing purely streaming, so if all you're doing is event streaming, bringing in a data stream in, it's probably not going to be as useful as you would think. Again, it's most useful when you start having separation between functionalities and you are driven in a request environment where you go from a clear start to a clear finish or a clear error. So quick hand rate, pretty simple. It's the number of requests on the network or your system at any point in time. And it can track anything for here. HTTP calls, SOAP calls, REST calls, middleware messaging, Kafka calls. It can be driven through a service mesh environment, Istio, Envoy, Linkerd inside of here. It really doesn't matter, because what really matters is the volume that's trafficking across here. Over on the right, for instance, the image is a little hard to see here, but for instance, what I'm looking at is in a different order. This is my rate that's going on. I am running about 19.9 requests per second that's coming into this. I have aggregated and averaged that over a 10-second period, simply because if the data goes up much higher than this, then it becomes almost impossible to show it purely in real-time space. I'm showing that my duration for the request start to finish is running about a quarter of a second inside of here. And then I'm currently running about a 2% error return rate. Now, 2% may concern you, may not concern you. I've had places where they wrote off anything under 1% as background noise. I have places where any error that occurs immediately gets flagged inside of here. But rate is really around how well my system is performing and keeping up with the requests being driven through it. In any environment that can fail on peak traffic is a target for rate monitoring. Even if you're not necessarily going to do the rest of the errors and duration here, you always should know what's going on in your rate request that are coming in here. A few years ago, there was a large e-commerce company who pushed a brand new service out on one of their busiest days of the year and promptly went down for about 5.5 hours. And the way they actually spotted it was they had request rates coming into the service that were normal and request rates coming out of the service that were zero. And so they quickly realized there was a problem. They quickly identified what service was. They started the rollback process. And after that, it got messy. But nonetheless, just knowing what your request rates are going to be. Also useful in a request model is the historical data that comes into play. And so the historical data actually gives me the ability to see if this is normal behavior or abnormal behavior as well. Sometimes it's security, for instance, request rate can be an interesting metric to monitor, simply because if you suddenly start seeing a bunch of failed logins off of a user ID, you kind of need to know if it's somebody who forgot their password or if it's somebody trying to crack a password. And the historical information will help you understand that. So rate, breaking it down a little bit more, is broken down into the requests per second here. In this case, it's over a 10-second period here. I can also see what the data is doing as it's coming in. So I'm actually, I think this is being aggregated down to about the 10th of a second range over a 10-second period for here, but I'm showing it coming in here. I can also show you what each service is seeing inside of here, and I can show you what the most active functionality is. Each of these pieces become kind of a useful environment to understand. Again, nothing unusual. This is a microservices-based monitoring platform. I happen to work with Splunk, so of course I'm going to use Splunk as my examples here, but you can always look for a request rate information and other pieces of information that live inside of here. Errors, we all have errors. Errors are problems that cause incomplete, incorrect, or unexpected results. The unexpected ones are the ones that bite you, by the way, for this. And it can be caused by code failures, load bugs, production loads, communication pathways no longer responding inside of here. One of my favorite philosophy lines around this is that testing for production is not the same as running in production. So keep in mind that you're going to see things even if you test for them. You're still going to see these errors that can start creeping in around what's going on inside of here. The difference is that errors tend to require really fast response. Waiting to resolve the error is not acceptable. Likewise, errors generally need investigation. And so you need to start being able to deep dive and go into high fidelity as fast as possible. Keeping all the data around for your error response is really, really kind of an important model when we get into this. We all deal with errors. We understand what happens inside of errors. And what Red happens to do is help me identify that the errors are occurring inside of an application, especially on microservices, will actually help me determine which services are reporting errors and which services are producing errors. In a microservices environment with hundreds or possibly thousands of independent services running, it is really important to narrow that field down as quickly as possible. And Red gives you the ability to understand that narrowing a field by simply looking at what's happening on a service-by-service basis. So errors, this one's a little excessive, very honestly, for this one, but I'm running almost 50% on error rate inside of here. And again, I can see what's happening with my error rate in here, and I could then actually go all the way into it and say, oh, the errors are showing up in catalog over this, information and see what's happening at any particular point doing an overlay. Again, red gives me the ability to both aggregate up as well as slice down, parse into the model and start drilling down to figure out what's going on inside of here. When it returns, for instance, you're going to see an error that's shown up here. In this case, payments showed me a 402 product. When it reports up, the error that was seen by checkout would have been a 500 type of error inside of here, and that would propagate all the way up to the top level point that I'm looking at. And so again, I can simply look using red, drill into it, and find out what the bottom level error that was reported is, as well as look up and see what the pathway of that error and how it occurred going across the whole works. Excuse me. So duration, the last part in this red environment, well, it's all about time. It's the ability to bring things into causal order. When did it occur? How long did it take? Do I know if it's slow? Why did it take so long? And what's responsible for doing that? This is generally the domain of what's called distributed request tracing. And these days, we tend to talk about sort of the three categories of open tracing, open census, and now open telemetry, which is the merger between open tracing and open census. Though it provides us the ability to bring in this data from our applications to look at the timing aspects. We live in an instant gratification world. Google likes to, Google report in 2020, updated from their 2017 report, points out that 3.7 seconds is about the length of time someone will wait for a web page to refresh before they leave the site for that. A much maligned Microsoft study from about 2008 says that the human attention span averages 8 seconds inside of here. We can't wait anymore to see what's going on here. And so red gives me the duration things that start showing up and make sense for us to look at, because we need to keep the individual person happy. Duration is usually shown in one of two ways. It's usually shown as a distributed a cyclic graph, or it's shown as a waterfall plot. Down here, you're seeing not quite the complete, but you're seeing a waterfall trace that's showing me where the time was spent on each piece. I can already tell you that I'm a little nervous about the fact that I've got 4 seconds inside of here. I'm not even looking at the whole thing here, but I can also see what's happening in all my microservices environments going across. And I can also take a look into what's going on as each source, error sources are happening inside of here. So again, I'm looking at the same set of red information, but now I'm parsing it differently so that I can find out more unique capabilities. Today, our modern applications are almost impossible to map or to understand in a single gestalt. And so we need our tools to be able to help us, and using distributed tracing gives us the ability to map out the request flow as it goes through the system. So red actually has this thing which needs to be able to look at multiple dimensions. And we've talked about rate errors duration, but that gives us two capabilities. It lets us look at the recognition of errors and look at the recognition of root causes. So traces usually map to duration, logs usually map to errors, and metrics usually map to the rate functionality. That doesn't mean that you can't find that information in any of these others here, but we have the three things that we're tracking here. We have a couple of dimensions of what it helps us do inside of here. And in a sense, this becomes monitoring at the Chuck Norris level. It's not just see something, it's now and say something, it's now see something and actually do something. And so that becomes a really important environmental element when we start looking at what's going on in our systems. So what does red actually mean? Well, red is actually really easy to remember. I pretty much would be willing to place a bet that if you listen to my talk, you could tell me what red stands for. And so again, rate error duration is really easy. What we've also found in working with clients is that it reduces this decision fatigue issue. the number of times that the different groups will discuss, using the word discuss loosely here, what do they want to monitor? And so nothing actually ever gets done. And so there are no monitoring because we're always arguing about what gets to monitor it. Well, Red reduces that decision fatigue by giving us a clear starting point to which we can then expand, extend, and drill into. As you've just seen, I can drill into it and look at different aspects of the data. I can also design my own additional functionalities and drill in multiple ways in a Red environment. So that gives me the chance to start. People target shoot much better than they do in building targets. And so Red gives me a starting point that everybody can agree with. It also gives me a common language. I now have a lot of different people that can be doing this from a lot of different sites dealing with different pieces. And so the language consistency means that if I have a problem and I need to pass it to another group, they understand what I am telling them without having to go through a definitional process here. Red also, because of its metrics capability, serves as ability to do automation. For instance, we can do auto remediation across the environment should I suddenly see that I've pushed a new service and my error rate went up to 50%. I probably would suspect that that service is the problem. I would roll it back, which is going to respond to the issue and then resolve the issue without impact for my production systems here. And finally, it serves as a proxy for that user happiness piece here. And the user happiness thing we talked a little bit about is where people expect things to happen pretty much as fast as possible for this. This brings us into two things here. There's actually two levels of user happiness here. One of them is the external, the customer's view. Customer cares about this request, how long it took, and whether it was successful or not. And each time they issue a new request, that's what they care about. That request, how long it took, whether it was successful. As a operator, as a person whose job it is to keep things running smoothly, we need to aggregate those. What's all of the requests? What's the latency across here? What's its overall rates? What's its concurrency? What system aspects is it using? And so that becomes a really important aspect to understand. We need to be able to go from Red, which is the aggregate viewpoint, to all the way down to a individual viewpoint and take a look at what's happening with that specific use case. And again, Red gives me the ability to go from the broad view all the way down to the narrow view. Look at the aggregate space all the way down to the individual request trace. So pop the second poll, please. So you've heard a little bit about Red, and I'm just curious of which of these things, if any of them, match up to what you think might be most useful to it. I always have trouble, after coming up with this, I always have trouble picking which one I think is the coolest aspect, personally. So let's take this poll and we'll step into the next slide. So while I've really talked about Red and made Red sound like it's the perfect answer, there's also some things here, and it's what we call crossing the streams for that. And the issue is that any of these rate error durations can have problems that are actually caused or showing up in some other place. So for instance, if I have an error that appears, it could be there's a response time mismatch or there's a bandwidth limit, being very familiar with bandwidth limits today for this. Duration could be caused by network traffic, or it could be caused by something not coming back, or it could be caused by a slow consumer now hitting too much rate traffic to be able to respond back to it. And so each of these pieces can actually indicate a problem where the problem actually resides in a different area. So again, it's nice, and you can use a single one of these, but all three together give you the ability to see the entirety of your application space and what's happening across all of those different pieces. So with it, keep in mind, it's not just the infrastructure and it's not just the application, it's actually both. You need to be able to understand the application space, which is your duration and activities, but you also need to understand the underlying infrastructure space, because that's going to drive a lot of your communications and networking and your request traffic inside of there. And so each of those things becomes really useful information for that. The additional things that you keep in mind is that we are now talking about complex environments, and we're talking about environments that change, and we're talking about environments that can be ephemeral. If we have a serverless environment, an AWS Lambda, a warm startup time for Lambda is about 30 microseconds, and I think the current average is about 15 seconds for the Lambda execution. Most of the ones I've worked with have been less than a second in execution. When it's gone, it's gone. And so we need to be able to make sure that the tools help us track what's going on inside the system, even when it's not there anymore. And finally, this is personal, in my opinion, but if you can't drill into it, why bother? You can look at this thing and say, oh yeah, it's broken. But if you can't figure out what's broken, it's not worth your time in seeing that it is broken to begin with. So my philosophy thing, I actually I ran a nonprofit called Philosophy Talk for a while here, so I get to add philosophy to this here. So in dealing with this, we actually have to instrument. If you go all the way back to when I was talking about the observability nature, we need to be able to get the data from inside the application. So instrumentation is really useful. By itself, it's not an answer. It's not, oh, look at the really cool data I'm bringing in here. But I'm also going to add to here, avoid data ingest lock-in. Don't depend on somebody's really cool proprietary features. There are lots of really good open source tools now to help you bring data into here. Metrics are powerful. I mean, metrics drive alerts. Metrics drive response. Metrics drive incidents inside of here. Metrics are probably not enough. You're going to need more data, particularly around duration on application space, and all the way down into the truth that is the logs about what the application thinks it's doing. You need to look at the work that's going on, not the service. But you're going to look at the service anyway. But you want to see how the service responds to the workload. Did the service respond correctly when my request rate went up 10-fold or 100-fold inside of here? And finally, the goal is not observability, but reducing your mean time to detection, response, resolution, and repair. And so those are sort of the philosophical elements that are really useful to keep going inside of that model here. And so some takeaways. Red gives me a common structure for monitoring that allows me to have clarity even in separate teams here. And it gives you the ability to tailor the focus to your specific needs while providing that common language. And Red has been well proven to give you the cleanest, simplest completeness for microservices monitoring. So Red gives you the information you need to understand your applications and infrastructures and how they're working together. I'd also consider spending some time and looking at utilization, saturation, and errors, which is more focused on the operational aspects. And the two together will cover almost all of your capabilities and your functionality and work really well hand in hand. So with that, I'd like to invite you to also take a look. You can see the overall our product Splunk's observability product set. You can see the demo at this link. We also have an upcoming workshop. If you really want to get your hands deep into what Red means for you, I'd suggest dropping into this workshop and understanding not only what it can do for you, but how you can implement it right now today. So at that point, let me turn it back over to you, Patrick, and we'll take a look at some of the polls and we'll answer some questions.
That's great, Dave. Thank you very much for a great presentation. Just wanted to make sure that everybody sees that there's an offer that just popped up on the screen as well. So if you want to check that out, you can. So that's one thing. And let's go over to the new questions in Q&A. So if anybody has any additional questions, make sure you get those questions put into Q&A so we can answer them right now. Dave, let me know when you're in the Q&A. There's first one here from Rodney Berkheimer.
Yep.
So his question is this a Splunk plugin or independent of Splunk?
So the concept of red is completely independent of Splunk, and it actually is available in lots of places. I will admit, got first introduced to the red concepts using Prometheus, and sort of fell in love with what it would tell me about my running system inside of that. The Splunk tie-in is that our products also provide you all of the red data as well as that drill-in capability that you need to have. So red, totally independent of Splunk. You'll find that from lots of different vendors. You'll find it in a lot of different open source elements as well. But its job is to make sense of your complex application environments and how they work with the underlying infrastructure.
Great. So just wanted to make another plug. We have a few other questions that came in through a couple of different sources. But if there's any additional questions that of the people who are still on, please go to your Q&A section, or you can go to the chat as well. But Q&A is the quickest way. Type in those questions. We do have a few more minutes here to cover the questions, so love to hear them from you. The next question is from Greg Woodcock. He's asking the question: multi-select or just coolest one?
Yeah, so I'm sure that this was related to one of the polls, and I probably could have spec'd out a little bit here. And the question, the poll at that point in time was, what do you see as the main advantages for red monitoring today? It was rather kind of interesting. I want to share a couple of results. Number one was root cause analysis and identification, because most of us are trying to kill problems as fast as they come in. And number two was automating alerts and responses. So these numbers are not going to add up to 100%, but it's still kind of interesting. My personal choice, just to let you know, is always customer happiness, just because I like saying customer happiness.
Excellent. I love the honesty. That's great. So the next one that we have that just came from an attendee right now, not from another source, but from Gary von Erden. Red is a concept and Splunk implements the red concept ?
Yeah, so if you change the word concept to a monitoring pattern, you're right. So red is a pattern that allows me to understand conceptually what's going on inside of my request-driven system. And yes, the Splunk tooling provides the monitoring visibility of the red data sets. So yeah, absolutely spot on inside of here. But again, there are open source tools that also provide you red concepts as well.
Got it. So from this, we have 4 other questions that came in from other sources. The first question is, does red help in multi-cloud environments?
Oh, absolutely. And in fact, we ourselves, I came in through the SignalFX acquisition. The cloud that we're driving automatically goes into multi-cloud environments. We don't monitor on a single cloud basis. We actually have to monitor multi-cloud environments. We also have to monitor in hybrid cloud environments. And so red, again, doesn't care where your infrastructure lives. It really only cares about the data it can extract from the application and infrastructure to show it to you. Works perfectly well in multi-cloud, hybrid clouds, public-private clouds, or anything else. Limitations are it needs to be request-driven.
Great. So that just caused a couple other questions. I'm not sure the direct result of that question, but a couple of new ones have popped up. Shavron, are these patterns specific to infra or also user activity?
So it's rather, so red is mostly, oh gosh, that was a tough one. So red starts with the user level activity and then drills into the infrastructure underlying it. And so it's looking at how the user's behavior inside of your system is. We all know that the infrastructure, if you have a node that stops responding, your users are going to see it as something not working correctly, but it's actually an infrastructure level problem here. So it starts from the user viewpoint, the application viewpoint, and drills into the infrastructure. Its companion use actually starts from an infrastructure basis. And that's really kind of important inside of that. So that's actually kind of a useful model. And that was a great question.
So, and then now we've got another one from David. Would you say that red would be a good concept when trying to develop or architect an ITSI glass table?
Oh, well, hi there, Splunk user. Sorry for here. Red is actually, so I'm biased. I love the concepts of red. It has solved more problems for me in trying to figure out why I have an unhappy user than anything else I've ever touched in my life. I would always say red is a great place to start. Again, keeping in mind that it's really focused on services-oriented request behavior. So if that's if that's the model, piece of cake, go for it.
Okay, and got another one. Red is implemented in Signal FX using metrics and trace events, then gives drill down to Splunk for logs. Is that a fair statement?
Today, that is an absolutely correct statement. We provide the red metrics sets coming in a streaming model. That's why we can give you as close to real time as possible here. We are using the open telemetry model. We are the leading member of CNCFF. We are committed to open telemetry as its model. Right now, it does drill into the Splunk investigation and Splunk logs, carrying across your forensic data. You don't repeat your investigation. It carries the data for you.
Got it. And one from another question from Johnny Blizzard, which has got to be one of the all-time great names. How can we implement this?
So again, it depends on where you're starting from. But generally speaking, you are going to do some level of instrumentation. I would recommend an auto-instrumented approach where you don't change your code for this. If you happen to be in a Java world, it's really trivial to drop in an auto-instrumented agent and get to the data within seconds for this. Otherwise, you're going to be spending a little bit of time looking at the library functionality that happens. Open telemetry, again, a great place to start here. We offer the capabilities for smart agents to be able to do that instrumentation for you. One thing I would suggest, particularly for a starting point, is to not manually instrument your application, simply because manual instrumentation gets to be a pain if you decide to change things. Keep in mind that there are a number of open source projects that will give you red out of the box to give you the starting experience inside of that. And no matter what, pull something and try it. I think you'll be pleasantly surprised with the amount of information you get from even a simple red implementation.
Got it. So before we get to the last three questions, I just wanted to make a plug that Dave's got his email address up on the screen right now on the slide. So if you have additional questions, want some more information, please jot that down, davemc@splunk.com. Just make sure you get that before we end the webinar. We do still have quite a few people still in the system watching and listening. So we have three more questions. And the first one is, do I have to have microservices to use red?
And the answer is absolutely not. It was designed and implemented with microservices in mind. But if you have the ability to track a request going through your system, which basically means you need a unique identifier, you can use that for a red pattern.
Okay. Second to last question. Are there other monitoring patterns I might want to use?
Yeah, and I did mention one of these during the talk called utilization, saturation, and errors. Brenda and Greg came up with this, and it's the counterpart for the operational side. Use is really designed for you to understand what's happening in the system currently and where the system is hitting potential backlog conditions. And so it starts looking at the queuing and the activity that the system is unable to process because it's too busy doing something else inside of here. They map up really well. In any case, no matter what, I would suggest taking a look at, I'm going to pitch two books. I'm not going to, I don't remember their name, the authors here, but Google put out one called the SRE Handbook, which talks about golden signals, which is quite useful to get an understanding of why we're doing this monitoring level. And then there's one called Practical Monitoring, which goes into more information specifically about each of these capabilities and what they can do for you on a daily basis.
All right. And our last question, does Red replace the monitoring I am doing now?
It depends on what monitoring you're doing now. If you are doing traditional black box monitoring, quote, are you alive? If you are only doing that and are happy with this, Red's going to be an overkill for your environment here. Red is really targeted towards understanding the customer, the end user experience inside of our applications and our systems. So if you have the ability, or if you have the need to know what your customer thinks about what's going on in your application space, Red is great for that.
Okay. And actually, we got two additional questions, which will be our last questions just because we're running out of time. But when a unique identifier like a correlation ID is used, how can we look at the metrics at different level, like Exchange, and then the application level?
So this gets us into a broader category, and maybe we'll come back at some point in time and spend some time talking about the real user level here. So we have both the client side and the server side inside of this. An Exchange backend is a service, and that service can connect to an application level, and it's going to connect through some level of communication pathways. With those three things, I can now do, at the very least, an inferred service model, which comes back and gives me the duration information, gives me the error rate information, and gives me the rate to which I am passing and receiving data from the service. What it's not going to be able to do is allow me to look inside of that specific service. So Red will give me the information in and out, but not within.
All right. Well, Dave, thank you very much for such a great presentation. It obviously brought up a lot of good questions from our audience. We want to thank everybody for the great questions. Again, if you have further questions for Dave, make sure that you're getting his email address, davemc@splunk.com. I'm sure he'd be available to answer any of your questions. But before I finish everything today, I just want to say thank you, Dave, for the great presentation, number one, and Splunk for their sponsorship of today's online learning session. Also want to remind all of our attendees again that there is a recording of this session. It will be available in 24 to 48 hours. So you'll be getting an email notification of that it's available, and then you can also then forward that on to your coworkers as well. The recording will also be added to the Dev Network and Developer Week content archive, which is found at devnetwork.com. So at any time, you can go back to devnetwork.com and you can look under our content part of the website. It will give you all of our past webinars. Great opportunity to get some great information, which will also include this terrific webinar that Dave just did for Splunk. So want to thank you all for participating. Dave, thank you very much. And everybody have a great and safe day.